Physical science time. The lights are on here. We're going to be talking today about. I have a sticker on my finger. We're going to be talking today about two things. First, we're going to be talking about manipulation, and I don't mean when your mom says something like, "Oh, it would be nice if the trash were taken out," and she means Cody, take out the trash, but she says that other thing passive aggressive. That's manipulation, but that's not what we're talking about. We're also going to be talking about unit conversions, which is sometimes called, and I call it this, in parentheses, dimensional analysis. And these things are they're not directly related to each other. One of these things does not, as I was telling you before the video started, these are both things that we need to know for physical science. These are things that we need for the business to actually do physical science, but they are not directly related. You don't have to learn manipulation first and then unit conversions. You can learn unit conversions first. So, you don't know what either of these things is. You probably actually do know what both of them are. You just haven't heard them called this, maybe. And you don't know how to do them correctly. And that's my expectation. And I don't mind that. I want to teach it to you. It's almost like that's my job. But which one of these do you want to do first? Josie? Okay, we're going to do unit conversions first. Thank you, Josie. Thank you for being decisive. Sometimes you ask someone, where do you want to eat? And they say, I don't know. And that's really annoying. So if you had said that, I would have been annoyed, but I would have been nice. Probably. Okay, so we're going to do unit conversions first, which are also called dimensional analysis. Let's break this down just a little bit. What's a unit? Give me an example and tell me give me some kind of definition. Centimeters is an example. What is a unit?
Measurement.
Yeah, it's if we're talking about, how much do you weigh, Garrett?
Like 135.
Garrett weighs 135. I assume you mean pounds.
Yeah.
This is almost like a little statement. It's almost like if we put Garrett is 135 pounds, what part of speech is 135? Do you know? If we're analyzing this as a sentence, Garrett, I just always going to do two R's and two T's because I never remember which one is doubled up. Is, okay, what's this? What part of speech is this? Come on, you know this. Mrs. McClendon is not going to watch this video. Is a verb. Verb. Is a verb. Yep. 135 is a...
No. Unit.
Try it. No, pounds is a unit. What? Helping noun. What do we call a helping noun, babies?
Prepositional phrase.
Oh golly. It's an adjective. It's describing the pounds. 135 noun or numbers are always adjectives. This is an adjective. This is this is the noun. I thought that would be a lot easier. I'm really sorry. I forgot that it's August and you just got done with summer break. The noun, this is the more important thing, right? We can have the sentence doesn't work if we don't have a noun. We can't just say Garrett is 135 because Garrett is 135 what? Years old? Cockroaches in his shorts? I don't know. 135 doesn't mean anything without the noun, the units. Okay, so this actually, weirdly, this demonstration usually works, and you realize that units are important. But in this case, I'm not sure you do. But units are the most important part of a quantity. So units are the most important part of a quantity, and they tell how a thing was measured. Tell how it was measured. That's what units do. They say how it was measured. Is it the same if I just say, Garrett is 135? You might, from context, know what that is. But Miranda, if you were just walking down the street and you found someone, you said, Garrett is 135, they wouldn't know that you meant pounds. They would probably assume you meant years old. If you said Garrett is 5'8", they might realize that is a height even without units, but that would be an inference. He might be number 58 on the football team. I don't know. But the numbers, what I'm pointing out is that numbers are at best ambiguous without a unit. That means that they could mean a couple different things. 135 years old, 135 pounds. At best, they're ambiguous without a unit, and at worst, they're completely meaningless. If I say that window is 3, What does that mean? 3 what? It doesn't, we don't know. Maybe it's 3 panes, maybe it's 3 meters tall. It isn't, but just doesn't mean anything. Do you see what I'm saying? You have to have, you must, I rarely put this on the board. That's you, each one of you, Brinley, Wes, Sage, all of you must have a unit with, I'm going to put every number. There are exceptions. I'm going to put every with an asterisk. I don't like, I've learned recently not to use absolutes where I shouldn't be using absolutes. Some numbers really are unitless. Some numbers don't have a unit, and we recognize them as that, and we use them where they're needed. But almost all the time, every number should have a unit. I put every with an asterisk instead of almost all because almost all makes it seem like you can decide when to put a unit, which is not the case. Some numbers are unitless. An example of unitless numbers are ratios. Like a gear ratio, if the gear ratio is 3 to 1, 3 has a meaning and 1 has a meaning without having a unit. And then conversion, what's a conversion? We've moved on. We know what a unit is, hopefully, and it was the SI specifically, the SI system of units is one of your vocab words. And we talked about units last year, so you should be good on this. What's a conversion? What does conversion mean?
One unit to another.
Yeah. So changing from one to another. Perfect. Like the catalytic converter in a car converts nitrogen dioxide into nitrogen and oxygen. Because nitrogen dioxide is poisonous in a greenhouse gas, and nitrogen and oxygen separately are fine. In fact, oxygen is pretty good for you. But that converter changes something. If you undergo a religious conversion, you change from whatever, I don't know, Methodist to Jewish, I don't know. That's a conversion. You've changed. A conversion means, so we're changing from one to another. And let's break down this a little bit. This is kind of a fancier way to say it, but dimensional analysis means that we are analyzing, like looking at, with our little binoculars, you got to look a little closer to find out what you want to know, and then we're analyzing, we're looking a little closer at dimensions, the size of things. If I ask you what your dimensions are, you might tell me your height and your weight and your circumference, yeah. Which if you're a boy, you probably know your waist circumference because that's how you buy jean pants. If you're a girl, you just know 6 or 2 or whatever. 29, says Cody, making some of us feel bad. So we're talking about the looking at of different sizes, and this implies unit conversions because the conversions are how we analyze the units, the dimensions. So let's have an example. Let's do a really basic one. Let's say, and there are several things about this that you'll have to memorize, and we'll talk more about them as we go on. But let's say we have a person that is 4 feet tall. Who?
Oh my gosh. Oh my God.
How tall are you, Tommy?
I don't know.
Uh-oh. How tall are you, Tommy?
4'9". That's a lie.
We'll say Tommy's 5 feet tall. 5 feet. And we want to find how many inches tall Tommy is. I feel like we really hurt Tommy's feelings. So let's all... So 5 feet to inches. You don't have to... This part is not one of the steps. This is just the very basic way that I sometimes give you a unit conversion. Saying that we have 5 feet and we want to convert the unit to inches. Okay, so you'll sometimes be your next bell work will be something like this. It'll say convert the height of the scoreboard 23 feet to meters or something like that. But it'll give you a number in a unit and say convert it to another unit. Okay, here's the first step. Step 1, and you should write down these steps, and you should maybe even actually what I'm going to do is I'm going to write it and I'm going to indicate what each step is as I write it. Step 1 is to write the given. 5 feet is the given. Do you know what I mean by given? You use this phrase in math or this word in math sometimes. This is step 1, which is write the given. Write the given. I'm going to put given in quotes because that's implying, or it's referring to the quantity that was given to us. You just now were given Tommy's height, 5 feet, and we're going to write down the given. Step 2 is to draw what I call, and as far as I know, I'm the only one who calls it this, but this is step 2 is the conversion, I'm going to put in quotes again, bar. What is this? What do these symbols represent?
That one.
What's this one? Yeah, multiplication. I don't usually like the x for multiplication, but here we use it. You can use a dot if you want. I don't love that either, but in this case we do. I just use an x. I think it's easier. What's the line probably represent? We're going to put numbers both on top and the bottom. Division. So our conversion bar represents a multiplication by a, what do we call this whole thing?
Conversion bar.
No, when there's a number on top and a number on bottom, we call that thing a fraction. Yeah, we're multiplying by a fraction. Number 3, with the squeakiest marker, is we're going to input our conversion factor. I'm going to put in parentheses here, must equal 1. I'm going to write the word equal because otherwise that looks stupid. Must equal, don't say stupid, must equal 1. So this is the part where people do get messed up. Up until now this is pretty easy, but this is the part where people do get messed up. I would encourage you to start by this unit is in what part of a fraction?
Top.
Yeah, this is the top. It doesn't look like it's in a fraction, but that means it is in the numerator. We could rewrite this as 5 feet over 1, right? So this is in the numerator. If I want to reduce out something that's in the numerator, I need to do what with it?
Multiply.
Try again. Divide it. So I need to put this unit in the denominator to get rid of it. Does that make sense to you? To eliminate it, to reduce this to 1, I need to get this in the denominator. So what I always recommend is start by putting the unit you have in the given on the other side. So if this was in the numerator, we put it in the denominator. And then what unit are we going to? What unit are we trying to convert to? Inches. So we put that in the numerator. So far, so good. Is that true? Is it so far, so good? Sure. Okay. I think you'll see in a second whether this is not that bad. And then we ask ourselves, you say to yourself, self, how many inches are in 1 foot?
12.
There are 12 inches in 1 foot. Do you see that this conversion factor is equal to 1? 12 inches divided by 1 foot, these two things are the same thing, aren't they? 12 inches is 1 foot. So if we divide anything by the same exact thing, what are we effectively multiplying this all by? 1. We're just multiplying it. It's effectively not changing this value at all. Does that make sense? That since these two things are identical, they're not exactly the same, but they are numerically equivalent. That's not true. They're not numerically equivalent. They are conceptually equivalent. 12 inches is 1 foot. That we're not changing the value of this. We're going to change the number mathematically, but we're not changing the value. So then, step 4, this one's going to be orange, go Rams. Step 4 is solve by multiplying by numerator and dividing by denominator. So 5 multiplied by the numerator, just the numbers right now, 5 multiplied by the numerator, which is 12, is 5 times 12 is 60, divided by the denominator, which is 1. 60 divided by 1 is still 60. So our answer numerically is 60. Our answer numerically is 60. Is that good enough? Nope, because every number needs to have a unit. And so we see that feet reduce to reduce to 1. That's what Mr. Sinley prefers me to say. You might say drop out. You might say cancel out. I know Mr. Sinley does not like that kind of loose terminology with math, so I like to say reduce to 1. Feet reduce out, reduce to 1, and we're left with inches. So our answer is 60 inches. Boop. 60 inches. This is a unit conversion. We've converted this quantity, Tommy's height, into inches. Is Tommy 5 feet tall? Let's pretend she is. Come on. Is Tommy 5 feet tall? Is she 60 inches tall? Yes, those two things mean the same thing. All we've changed is the unit. We've only changed the unit, and we had to do math to do that. Do you have questions about this? I was going to ask does that make sense, and that's a garbage, useless question. Do you have questions about this? We will do them more, and we'll do them faster. But I want to show you a couple of other things first. And we'll probably, in fact, almost certainly, we will be doing more of these tomorrow. There are a couple different things we have to learn before we can complete that worksheet. But this is the most basic kind of unit conversion. Let's do another one. Ready? Let's do seconds, sure.
Let's do 565,900 seconds.
That's a really That's a really specific conversion you want to do.
In 2 days.
In 2 days.
Oh, you want to convert it to days?
Yeah.
Nah. Let's. Well, okay, let's do it. You know, you asked for it. That's fine. Let's do it, and we're going to get a little bit ahead of ourselves, but that's what I've been told we want to do. So you said 565,000.
900.
Oh, sorry. Heavens, 900 seconds, and you want to convert it into days.
Yep.
Okay, well, let's do it. 565,900 seconds. Conversion bar is step 2. Okay, so I wrote the given in step 1. Conversion bar is step 2. What unit do I want to get rid of? Seconds. And it's in the numerator, so I need to put it in the denominator. Can I go right from seconds to days? And when I say can I go right from, there's no conversion factor that I know of, that I have memorized, that can convert from seconds to days. That is to say, I don't know how many seconds are in a day. Do you?
No. What did you do?
No, I know it's 60 times 24, but I don't have the wherewithal to do that right now. I'm trying to teach a class. So I'm going to instead convert from seconds to hours, which you can abbreviate either H or HR. And then hours, see, look, hours is now in the numerator, so we want to get in the denominator to reduce it out, to days. This method is called, once again, I've never heard anyone else call this, but I call this chaining. We've chained together 2 unit conversions. And listen to me when I speak to you. Do you look at me right now? Look at me. Put the units in first before you put the numbers in. I'm telling you, I always tell people this, and they think that I'm crazy, I guess, because people don't do it. Put your units in first. Just like this. Do you see how I have units in without numbers?
Yes.
This, to me, makes it so much easier, because if your units are right, your answer will be right. So seconds are going to reduce out, hours are going to be reduced out, and then we're going to be left with days. Then, once your units are in, you go back and you ask yourself, how many seconds are in an hour? Self?
3,600.
So in 1 hour, you put the number that goes with it on the line. There are 60 seconds. I don't know what you were talking about. Oh, I'm sorry. Yeah, you're right. 3,600. Please forgive me, Lucas, because I made a rude comment about you, and you were actually right. In 1 hour, there are 3,600 seconds. Could you have gone from seconds to minutes and then from minutes to hours, making another link in this chain? Yeah. You know what? There's more than one way to skin a cat. You can usually, any of these multi-step ones, there are usually a couple different ways to do it. So if when you're cheating, you look off of someone else's and they have it wrong or different from you, they're not necessarily wrong and you're not necessarily wrong. You might be. You might both be wrong because you're freshmen. But you're not necessarily wrong just because it's different. There are more than one way to do these. 3,600 seconds in 1 hour. Thank you, Lucas. I'm sorry, Lucas. And in one day, there are 24 hours. So now I need to take this number, my given, multiply it by 1, and then multiply it by 1. Do you actually have to do that? No. Take this number, divide it by 3,600, listen to me carefully, press enter, and then divide it by this. Otherwise, what it'll do is it'll divide this number by this, which will give you a smaller number, and then divide this by only that number, which is not right. So you need to take this number, divide it by this, and press enter, and then divide it by this and press enter. Do it now. There are calculators in the back of the room. Or you can use your Chromebook. Hurry up, Garrett. I love, since this is a class where we do math now, I love for 2 people at least to do it so we can corroborate.
It's 6.54976851.
Okay, now check it out. Do we need all those dadgum numbers? No. Let's go to, we have 4 significant figures here, so let's go to 4 significant figures. So 6.
4.
What?
4.
Why did Cody lie?
Sorry.
5, 4,
Rounding.
4. 9.
9 what?
7.
Okay, so yeah, Cody was right. 550 is what we would put. So 6.550 what? Well, seconds reduce out, hours reduce out. This is days. About a week. You've experienced a week. It was almost about this many seconds. Maybe like 600,000 seconds. What does that make you feel like? Garbage, yeah, good, thanks. So we have here a basic unit conversion with the steps that I hope you wrote down. We have one where we chained them. And tomorrow we'll come back and do rates because I do want to get to manipulation first. But we'll do rates tomorrow, which is where we have a unit in the denominator too. Something like miles per hour, miles divided by hours. We can do those too, but we're not going to do them right this second. I had another thing. Oh, there's a kind of a step 5 here, which is check for reasonability. check to see if this is a reasonable answer. Does it seem reasonable? You don't have to do the math all again, but does it seem reasonable for almost 600,000 seconds to be about a week?
Yeah.
Yeah, that seems reasonable. That way, like because you can pretty easily get these things flipped, and you end up with 600,000 seconds being 10 to the 30th days. Does that make sense? No, that means you did some math wrong. This is just a nice little check. Does it make sense? Does it feel like it makes sense for 50 feet to be 60 inches? Yeah, but actually it does, because that's right. I'm sorry, 5 feet to be 60 inches. Thank you. Good job. I did that on purpose. I'm not stupid. 5 feet. Does it make sense for 5 feet to be 60 inches? Yeah, that does make sense. So you just check to make sure. Actually, I think we would be better off doing rates now, because it seems to me, I don't know what's going on in your brain or your soul, but it seems like you're kind of getting this at least faster than some people sometimes do. So let's just go on and do rates first, and then we will do the manipulation tomorrow. So I'm going to erase that. We'll do the manipulation tomorrow. I'm going to erase this one. I hope you had all this written down. I know you did, because it's been up there for 10 minutes and you know my expectations. Let's do a rate one. So let's say for instance that let's flip our paper over just for fun. We're going to flip it over. And let's say we had, are there not any on here? This is a bad worksheet. I'm sorry. Let's say we had, how fast does your mom drive? Too fast. Give 80. Yes. Good. 80. Let's say your mom is driving 80 miles per hour. I wrote it like this. I might even put it like this. 80 miles per hour to, let's go miles per, let's go feet per second, which is sometimes abbreviated FPS. Let's say we're going to use the unit that people use for firearm muzzle velocity for your mom's driving. Okay? So feet per second. We're going to go from 80 miles per hour to feet per second. So far, so good. Yep. You understand what we're kind of trying to accomplish. We're trying to see how many feet your mom is going every second that she's driving 80 miles an hour. So 80 miles, I rewrote it like this, first of all. You need to do this. You need to rewrite it from MPH, this means nothing, to miles divided by hour. The per means divided by. We talked about this last year, so you were good on that. Miles divided by hour. You can do either one first. I like to do the one in the numerator first. So what are we going to change about the numerator? We're going from miles to feet. The feet part of that is in the numerator. So miles to feet. And then we also need to convert this denominator unit. If it's in the denominator, where do I need to put it to make it reduce to 1? In the numerator. So I put hours up here. I wish I was using the same abbreviation all the time for hours. There we go. I need to put hours up here. And what do I need to convert that to? What do I need my denominator unit to be? Seconds. Good. If I did both of these, would that get me my desired unit, feet per second? Yes, it would. And now I ask myself, how many feet are in a mile? Does anyone know? 5 tomatoes. 5 tomatoes. Stupid. 5,280. Well, the reason I don't like that is because there are some other measurement systems that are good that use numbers like 10 and 100 and 1,000, and you just have to move a decimal place, but this is garbage. Anyway, you do have to have it memorized because the world is garbage. 5,280 feet in 1 mile. How many seconds are in an hour we already talked about?
6.
Try again, because I made that mistake earlier and you guys ridiculed me. 3,600 seconds in an hour. This is called a rate conversion because this is a rate. We're talking about a unit per unit time. Unit per unit time is a rate. So, math it up. 80 times 5280, enter, divided by 3,600. Do you see how I got those numbers and where they came from?
5,280 times.
Do your work, Friendly. I hope that didn't get picked up on the mic. That would be disgusting.
And then divide that. 360.
117 and a third, right? 117. So let's put, for this, we're going to put 120 feet per second. I'm going to rewrite this a little different. I'm going to show that, look, miles reduced to 1, hours reduced to 1. We're left with feet on top, seconds on the bottom, feet per second, which we can rewrite if we have to as 120 feet per second, FPS. So this is about, if your mom's going about as 10th as fast as a bullet. Like I know like some 9mm bullets are going about 1,200 feet per second when they come out of the firearm. So your mom's going at 1/10 of the speed of a bullet when she's flying down the highway. She needs to look out for kids, though, because what if that, or like raccoons and turkeys, because you know what, if you hit a turkey going 80, you're, not just your car is totaled, you're totaled. Bye.
That's 40 yards per second. That's a long.
I said bye.